Good morning to everybody. I will start the next talk of this session with all the distinguished scientists here. And I think much of the geothermal has been already explained before in 2 slides. I don't have too much about it. Just have some glimpse of the world geothermal as well as Indian geothermal system. What are the can say energy sources presently? Most important, and particularly in India, and most used are fossil fuels, coal, petroleum, natural gas, and now coal-bed methane. It's also coming up. State energy, we have hydropower, nuclear, wind, and solar. They are all established. That is under experimental. Geothermal, we are trying our best to establish for the last at least 3 decades almost. I think with this meeting, we'll pick up quite strongly. Technologies, biodiesel, biomass, hydrogen cells, electric vehicles. Now different type of batteries also are coming up, lithium battery, sodium-based batteries, etc. The main geothermal thermal fields are mostly associated with all the plate tectonic boundaries. And the plate tectonics has given quite a big impetus to the geothermal research also. Plate tectonic boundaries, this is the Pacific Ring of Fire, that is California, Japan, Philippines, even a part of the Indonesia, New Zealand, that covers the main geothermal fields. India, Himalayan belt. It's also one of the major. Kenya in Africa. These are the main geothermal areas. And based on the geology and technology, plate tectonics basis now, even Peru and Chile also, they are coming up as a geothermal area fields, geothermal fields. What is geothermal? Geothermal is a new and alternate energy source, which is a continuous source of energy. It is a heat stored in rocks, which is brought to the surface by the deep circulation of the water. And this energy is a renewable energy. And it is a very sustainable energy. The plant in Italy, Larderello, is running for almost more than 100 years continuously. So there is a sort of renewability and sustainability in this energy source. And geothermal is a environmental friendly energy, as there is no burning of fuel and there is no, we can say, large scale devastation of the forest. This is a very simple schematic diagram of how geothermal works. There is a, we can say, forest area or hill area or something deep area which is having a deep source, a deep fracture. Along with this fracture, the groundwater or meteoric water percolates down. It reaches to depths of 5 or 10 kilometers, around 5 to 6 kilometers, we can say, where there is a heat source developed because of different structural, we can say, geological structural availabilities. And the heat, that heat is collected by the water. It becomes a very quite hot mixture of steam and water. And wherever it gets a conduit, it comes to the surface in the form of hot spring. Once we get hot spring, we try to utilize that hot spring as a localizing for the geothermal field. And then we try to exploit it through drilling purposes, exploration, and get it to the surface for the different useful purposes. When there is no water circulation, groundwater cycle, geothermal water cycle is not developed, but the rock is hot. That is called as a hot dry rock geothermal system. In that, what we do, artificially we put water in the subsurface, and this water is used to create the fractures and collect the heat in the subsurface. That hot water is pumped up to utilize in the power production, power generation in the geothermal system, that is called as a hot dry rock system. What are the geothermal manifestations? Geothermal area is characterized by the main manifestations, that is hot water springs, steam emission and fumaroles. marshy land. Most of the geothermal areas will be having a marshy land because there is a lot of seepage of water, and that continuous seepage creates a marshy land. And mud pools, deposition of silica, sulfur, arsenic, borax, calcite on the surface. And sometimes there is a local subsidence, like we found generally in the Wairaki area of Wahaki area of New Zealand. This is a hot spring, Leha area, Chumathang area. The water is coming almost on the bank of the Indus River. So we are nearby, we are a cold water river, and we are a hot spring just on the bank of the river. This is how a steam and water mixture comes in a geothermal area, a sort of fumarole. The steaming grounds, particularly in Iceland. So wherever there is geothermal area, if the water is coming to surface, sometimes there is a lot of steam emission. And along with the steam emission, there is a deposition of different type of minerals, arsenic minerals, sulfur, borax, etc. And this is a field in geothermal field in Japan, which is showing a ample deposition of sulfur. There is always why we call it it's a environmental friendly, but in spite of that, there is always some sort of environmental concern. That is, a hot water will be having boron, arsenic, and fluorine content, which has to be monitored in every geothermal field. And silicon calcite deposition is always possible along with the hot spring as well as along with the production pipeline. Secondary products like sulfur, borax, cesium, lithium, etc. They are available, and it's means possible to extract them with the present available technology. The main gas emissions are CO2, SO2, NO2, NH3, nitrogen, helium, and argon. These last two gases, they are useful and they are can be extracted or separated for industrial purposes. This is the last one, land deformation and subsidence. It depends on the production rate and availability of the physical geological system there. What are the uses of geothermal? This is a very schematic diagram showing how geothermal can be used. These are the temperatures 200 degrees centigrade and above. Dry steam geothermal system can be directly utilized for the production purposes, that is electricity generation, hydrogen production, and mineral recovery also. Between 95, 100 above to around 170, 150, 60 degrees centigrade, it can be utilized by binary cycle power plants. And then there are other ancillary uses, food processing, industry, onion drying, etc., etc. And the low temperature, they are utilized for the basically for the aquaculture, then skin care centers, then as a very great tourist attractions all over the world. And heating and cooling means refrigeration or heating of the space, that is particularly in places like New Zealand or Iceland during the winter. The geothermal energy, geothermal water, we can say, shallow geothermal low temperature water is utilized for heating the houses, heating the buildings, and it's utilized in a very large scale. China, there is a province called Tianjin, where they are using, rather substituting the energy, electrical energy for heating purposes, almost 150 megawatts per year. So such a large scale utilization for heating and cooling purposes is also possible. I think this I need not explain because already it has been done, but this is a direct dry steam generator. Once steam is separated from the geothermal water, it can be directly utilized in a turbine to drive the turbine and generate the electricity. Second one is binary cycle power plant, which was explained by Dr. Saraswat, so I should not go again, repeat it again here. So what are the main uses of the geothermal? The main uses are binary cycle power generation, particularly in India, agriculture and aquaculture. This is a very large scale utilization in agriculture and aquaculture. Aquaculture means we have crocodile farming, we can have fish farming, and in agriculture, greenhouse cultivation, as well as particularly in places like Sweden or even Switzerland, clear the ground, large scale farms from the, we can say, thawing during winter, geothermal water is utilized. Spa, balneology, refrigeration and cold storage, then industrial applications and desalination. Nowadays, geothermal water is utilized for this purpose also. Greenhouses, sericulture. In Tatapani, when we started initial work, this geothermal hot water was utilized for sericulture purposes, and there was quite a good industry. Now, somehow it is not working there, but there are so many small scale and ancillary uses which can help local population in having some additional income, and extraction of rare metals and minerals. So how a geothermal plant can look. Area is, we can say, the forested area. In between there is a geothermal plant, and nowadays they are using air draft cooling also, so there is not a very high cooling towers are not required. Only thing, the main problem here is the steam emission. So that steam emission creates, we can say, a sort of humidity there. But otherwise, it's comparatively much cleaner power plant, we can say. This is a major use of geothermal. That is spa, bathing, and skin cure centers. These three tanks, they are having actually different temperature, and depending on the temperature, depending on your requirement, they are having even different water compositions also. So some will be slightly more salty, some will be having slight more temperature. As per requirement of the tourists can enjoy here from China. These are the aquaculture tanks, actually, different tanks with different pH conditions and different temperatures, and they are utilized for fish farming of different varieties. In any case, greenhouse, I think greenhouses are very common. Everybody knows it. This is the major use, particularly in New Zealand, Iceland, and then nowadays quite common in France also. That is a heat pump, heating and cooling system. During the winter, this is used for the heating purposes, and during the summer, it can be universally utilized for the cooling purposes. The hot water pumps means this piping is there, and the heat within the interior of the earth around 30 to 100 meters of depth, pipes go, and water is circulated through this as per the requirement, as per the season, and we can have both the cycles, heating as well as cooling. This is a quite a good substitution of the electricity, and it contributes to the, we can say, lowering of the carbon footprints. This is the place, Japan, where we used to stay, and they had utilized this heating and cooling system to heat the rooms there, hotel rooms. Complete hotel was just based on this heating and cooling system, on the geothermal heating and cooling system. What is geothermal? Geothermal is a site specific. That is one major problem with the geothermal. It is site specific. It is useful in remote areas. It is a renewable, environmental friendly, and now it is a technically feasible at all temperatures, all places. It can be utilized as per your requirement. Production units are available from a very small unit now, kilowatt to 100 megawatt size also. And now practically in India, we are having a 20 kilowatt power plant, which we are coming up. So the types of geothermal resources, two-phase, hot water and steam. Single phase, only steam or only hot water. This is called as a dry steam. And there is dry phase where there is no water and no steam, what is dry hot rock system. If they divided into potential wise also, the potential is 250 and degrees centigrade and above we call high potential. Intermediate potential is 125 to 250 degrees centigrade, and low potential is 125 degrees centigrade, which can be utilized for binary cycle and direct uses directly. Which are the main countries actually? There are 49 countries which are utilizing geothermal presently in the world. USA, Italy, Japan, Philippines, Indonesia, Turkey, Mexico, China, New Zealand, Iceland, and Kenya. They are the main countries utilizing, and most of these countries are almost producing geothermal energy, rather electricity, almost 1,000 kilowatts, megawatts or more. The distribution of the geothermal plants in the world. And Australia is also coming up, but then Australia, we have a dry hot rock system, and they are trying to produce electricity through this dry hot rock system. Rest of these are mostly steam-based plants. Turkey, France particularly, they are using low temperature geothermal for heating, cooling purposes and other ancillary uses. In USA, in any case, they have more than 3,000 megawatts of electricity generation by geothermal system only. New Zealand, in any case, is very famous, Auckland, Wairaki and Oahu. The diagram showing distribution of power generation in these main 10 states, and USA is producing almost 4,000 megawatts of electricity, followed by the Indonesia, which is 1,000 and more. Rest of the countries are producing almost 1,000 megawatts of electricity. This is the chart showing the direct heat utilization, that is heat pump, space heating, greenhouse, then crop drying and industrial uses, etc. That is also quite a heavy use nowadays. Comes to almost 1 lakh, we can say, megawatt thermal. Quite a different uses there. It can be utilized to substitute the, we can say, fossil fuel energy. So what are the possible uses, particularly in India? Thermal, geothermal power plant for temperature of more than 100 degree, 200 degrees centigrade, and binary cycle power plants are feasible. Food processing, fruits, seaweed drying, vegetables, onions, fishes, etc. Industrial uses, timber washing, sericulture. Low temperature, it can be space heating, vegetable cleaning, small scale industry possible at Puga, Manikaran, Parbati Valley in Himalayan belt. Then greenhousing, culture, and tourism. We have number of tourist localities in Himalayas, particularly Joshimath, even Leh, Ladakh, Chumathang, which we talk so much in the morning. It has become a very much important tourist center, to resort. 2 or 3 resorts are coming up there. And if you go to West Coast, there is one place called Tural, that is in Ratnagiri district. We have a very good geothermal resource there, and they are actually done by private people, and they are very popular. The carbon intensity of electricity generation was already discussed, but if you see wind around 12 to 12 grams per unit, CO2, 12 grams of CO2 equivalent per unit of production. Nuclear is 16, biomass is 18. Solar, no doubt, varies depending on the actually the type we are using. Geothermal is around 45. It comes to means 35 to 45, it's said. So it is a very low carbon imprint energy. Of the geothermal, this is one major factor actually discussed every time whenever we go anywhere, any meeting, any place, any seminar. What is the cost of it? It's said that it's a very high cost, but the thing is, the drilling cost depends on the rock type and the depth, geology, and the structure there, and to the depth you are drilling. Then the temperature, high temperature, if there is a high temperature, there is a more production, so automatically the cost also goes down. No doubt drilling cost is higher, but the overall production cost goes down. Then more the discharge, more the production, so automatically the cost is lower. Then water quality. If we have to process the water before production, then automatically the cost will go up. And location, mainland or hilly terrain. The cost in Puga is comparatively supposed to be higher than, suppose, if we are taking up the project in Tatapani or West Coast area, because of the logistic supports required. And the method which we are using, binary cycle power plant, or steam-based power plant, or the type of heat exchangers we are using, those things control the cost of the geothermal power plant. But one thing is, this was actually discussed in the ministry MNRE, and that is why I have put also. This has been number of times discussed in the international forum also. When we compare with solar or wind or everything, solar, whether it's a solar or wind, their production is hardly 8 to 9 hours a day. So the production of suppose 10 megawatt is there, we are not getting throughout the day, where the geothermal gets throughout the day. So geothermal power plant of 10 megawatt is equivalent to 30 megawatts of solar power plant. So that way, if you compare, the cost of geothermal will automatically come down. The levelized cost, particularly these are the international figures presently. I cannot say that they are really valid for the India, but the cost of geothermal will come around $0.08, that is around 8 cents to 10 cents if we go for a bigger plant. If we try to calculate the cost for the India also, particularly in Tatapani and Chumathang, which comes to around 8 to 10 rupees. If our production means plant capacity is around 3 to 5 megawatt. The same slide. If you see here, it's around 0.4, but this is in US with steam-based conditions, where there is a temperatures of more than 200 degrees centigrade. We are getting 4 cents per unit. That is the production cost. These are the comparative cost of geothermal with other natural resources, solar thermal. And in any case, there is a variable. This variable cost is 0.45 to 1. This is 0.4045 to $0.1. That depends on various factors just now I discussed earlier. The graph shows that if the resource temperature is higher, automatically the cost of production goes down. Higher the resource temperature, better is the production, lesser is the cost. Accordingly, higher is the well flow rate, means the yield is higher, hot water yield is higher, automatically the cost of the production goes down. So these two factors will generally control the cost of geothermal production. And this is the investment required. These are old data, actually 2015, but we can comparatively see if the hot geothermal water system is their magnetic geothermal system. The average megawatt cost is around $4 million. Hot sedimentary requirement depends on the number of, we can say, borers drilled. It's around $7 to $8 million. And what is called as a engineered geothermal system or hot dry rock system, it is much expensive. It is around $10 million per megawatt. The overall variable we have considered, and what can be the cost, average cost. These are the international figures, and this was study was specifically done for 2 megawatt binary cycle power plant in Indonesia. So they have found with the various different inputs, the cost of the production can be maximum around 8 cents, $8 per megawatt, that is 8 cents. 8 cents is around 7 to 8 rupees, Indian rupees. This was typically done particularly for the Indian conditions. This is 1 megawatt plant with 112 degrees centigrade temperature, which we are getting at Tatapani. The cost comes around 9 rupees per unit, 130 degrees centigrade. In the same Tatapani area, if we go for the 1 megawatt plant, it comes to around 7.3 or 7.5. The temperature is 130, and if it is 3 megawatt, it is around 6.5. As the temperature increases for the same capacity, automatically the cost is stabilizing around 6 to 6.25 rupees. Regularly, this was done, exercise was done for the Tatapani. It's 10 megawatt power plant, which was, this exercise was done by the Workis company in Iceland, and they found that the production cost be in India can be around 7 rupees. And this is the US standards, which comes to around four means around 4 rupees per unit, 30 megawatt power plant. But these are the American conditions, rest of these Indian conditions. So we have no doubt slightly, immediately we cannot compare with the solar, cost of the solar. But if we see the costs are manageable, if we go for the higher capacity and if we start a commercial production when things are available comparatively easily. Presently machinery is difficult, then drilling is a difficulty, then power production means power plant we have to import, so automatically costs are coming up. If we start making India indigenization, automatically the cost of production will come down. The power generations presently capacity in India, I don't want to go in detail here. This is the map actually of Indian geothermal fields. This is the Himalayan area where Leh Ladakh actually is some here. Then we get this Tapovan area, not Tapovan, Manikaran area, then Joshimath Tapovan area, then Arunachal Pradesh and northeastern areas. This is the central Sonata belt, what we called, where we are getting Bakreshwar, Tapani, Anoni Samoni, and then Unabdev, etc. This is west coast area where there are 18 hot springs. The northernmost is called Sativali, then Ganeshpuri near Bombay. Then we have a very promising Unavare Khed, Ratnagiri district, and the last one is Rajapur, which is a very famous temple. These are the places. In Godavari Valley, we are getting hot springs at Manguru, and at Manguru, GSI has done quite a lot of work where based on which the Singrani Collieries and the Sri Ram Institute of Industrial Research, they are putting 20 kilowatt plant. These are the different provinces we have divided in geothermal fields of India. Chumathang, which is a very hot place and hot in discussion. It's located 180 kilometers southeast of Ladakh in Jammu Kashmir. Now it is a union territory, no doubt. The elevation of 4,400 meters. Springs are spread over almost 3 kilometer area here. Surface temperature varies from 30 to 84 degrees. This is almost a boiling point there. 4 boreholes were drilled, out of which 17 boreholes were showing artesian flows and 120 degrees centigrade temperature was recorded in the borehole. And with the different parameters of aqueous, what we call as aqueous geothermometers, we are getting temperatures of estimated reservoir temperatures. That is underground temperatures around 2 to 3 kilometers of depth. We can expect up to 180 to 260 degrees by various methods. Range is very high, but it certainly indicates that this is a very promising field where we can get temperatures of more than 200 degrees centigrade. This is one major drawback there, deposition of sulfur and borax at Puga. But there is additional advantages. Cesium was extracted from the hot water of the Puga in association with BARC. So this is an additional attraction and it is a very useful nowadays because the Government of India is very much trying for the rare earths and rare metals, various we can say strategic purposes. It is space heating, hutment and poultry farming was experimented here. The photographs of Puga, this is a spontaneous, so we can say artesian flow. The photograph of Chumathang area, you can see here are the manifestations. Along with the hot water flowing there, there is a deposition of different, we can say what we call as a clay minerals and calcite. And this deposition is a partially of sulfur and arsenic minerals. That is where most of the geothermal fields actually look. Borehole in Puga, which was, this is a borehole in Chumathang actually, which was drilled in 2012 for DRDO. and this is giving 120 degrees centigrade temperature, and you can see almost 40 degrees, 40 feet of sprout. So the pressure here should be more than 1.5 bars. Field, this was just now we were discussing. This field is also very promising. It's hot spring up to 96 degrees centigrade and estimated temperature around 180 degrees centigrade. This is a major tourist attraction in Himachal Pradesh. And the hot water, GS had actually in collaboration with RRL established their one 5 kilowatt power plant long back, 30 to 40 years before, which was destroyed because of landslide. But presently, the hot water is utilized by Gurudwara for cooking purposes. So, besides this, geothermal water can be used for various ancillary purposes, and this is one major use. The whole almost, I don't know exactly, I have not visited that place, but they say that almost that kitchen with 2,000 capacity per day is totally dependent on this geothermal hot springs at Manikaran. Tapoban and Joshimath. Joshimath is near Badrinath. This is also a promising field, and presently we are getting some inquiries for development of this particular area. So the direct heat utilization particularly in this area is planned. Let us hope that something comes up here. Central India, Tapani, Babeha, Anohni. Anohni Samoni is near Pachmadi, which is also a tourist place. Tatapani is in Chhattisgarh district. This is a very promising field, which we'll deal here. And then, as I already discussed, the west coast area. Tatapani is where we had GSI drilled 26 borers. We are getting surface temperature, hot spring of up to 97 degrees centigrade. And discharge, out of these 26, 5 boreholes were giving hot water of more than 100 degrees centigrade on the surface. These were at the depth of 150 meters only. So at the 150 meters, we are getting maximum temperature of 112 degrees centigrade on surface. We are getting, when water comes to surface, it is around 100, more than 100 degrees centigrade. The discharge of individual well varies from 230 to 300 LPM. So total discharge here initially was 1800 LPM, which is presently now around 1100 and I think 1125 liters per minute. So with 1125 liters per minute and the estimated reservoir temperature of 160 to 190 degrees centigrade, we are planning presently with the available resource to have at least a demonstration plant of 100 kilowatt Tapani. The proposal is already submitted to MNRE, and last year it was accepted in principle. Overall power potential varies, no doubt. GS has estimated power potential of 17 megawatt. And there was a feasibility report. I myself was one of the members for that, along with the KDMIP ONGC in around 1995. It was estimated to be 11 megawatt on different parameters. And if we take the present data to the depth of extrapolated to 2000 meters of depth, power potential for the depth of 1500 meter to 200 meter means 500 meters of the, we can say, slab is estimated to be 30 megawatts. These power potentials are actually estimated for the binary cycle power only. We get higher temperatures, and if we go for suppose the technologically it is feasible to have steam based power plant, then the power potential will certainly go higher up. The drilling in operation at Tatapani. The overall view of the Tatapani field. You can see the area, it's a plain area, and there is a continuous steam emission. There are 5 boreholes. This is actually one borehole that is giving continuous steam when there is a flow. Boreholes are actually under control. And last 30 years, we are finding they are monitored intermittently. The temperature and discharge is almost normal. There is a hardly difference of 5, we can say 5%, depending on the season. Geothermal is a very sustainable resource once geothermal system is developed. As part of the TAT 23 boron, this can give a very good idea how the resource can be and how it can be utilized. Scientist actually from Schrumberger, Eastern Herrenberg had visited this place. When he visited this place, he had some very different type of idea, the development of this area. He said that in India there are no geothermal fields which are really worth developing except the Puga. When this borehole was opened, he had that now there is no further requirement to convince me that this field is worth exploitation. Anoni Samoni, this is a low temperature geothermal field near Pachmadi. But this has one very interesting thing. This has a 17% of nitrogen and quite a high percentage of the methane along this borehole. And that methane is continuously can be utilized for the, we can say, energy purpose. And it's presently it's used for bathing, not bathing, but burning purposes. So sometimes people cook food on that, burning that methane. The location of hot springs along west coast, Thana district, Ganeshpuri. In north में there is Sativali, Unavare Khed, and lastly Rajapur. The Unavare Khed is having temperature of 2 degrees centigrade, and actually 1 megawatt power plant was initially planned. There is one place called Tural here the Tural by Thermax. I think perhaps sir can talk about more about that. Ganeshpuri and this particularly Sativali, they are much useful for development because they have two advantages. They are on the main road as well as they have a lot of tourist attraction places there and tourist flow there. Temperature is one very important geothermal field. Though the temperatures are less here, 40 to 70 degrees centigrade, the flow is quite high. This Tantlo is around 20 kilometers away from Bakreshwar, which is also giving a temperature of 70 degrees centigrade with high flow. So there is one paper, I think, in this also, particularly this workshop we are presenting, that there is possibility that Bakreshwar to Tantla, this 20 kilometers area will be a continuous geothermal field. Very important aspect here is Bakreshwar is having 3 to 7% of CO2 and almost 3% of helium. I also worked in this area for Department of Atomic Energy, Calcutta. And we have not only confirmed this, we have confirmed a very high percentage of argon also. I don't remember the exact thing. And, I had suggested them to separate not only helium, but argon also along with this because both have very much industrial use. They have done some, BARC has done some, we can say, plant for extraction of helium, but I think it can be find much more to have better production. Guru field, it will be discussed by Sakre sir. Hot springs in Manguru are now, in any case, giving temperature of 81 degrees and 850 LPM. A 20 kilowatt binary cycle power plant is being tested there by CCL at Manguru. And this will be a first geothermal power plant if it starts operational in India. That is certainly there. So it starts a beginning of a small beginning which can lead ultimately to a major development. Springs in Gujarat, they are also at Dholera, Unai, Atri, Tulsi, Sham, Gujarat. And at Dholera, the PDPU, now it is a Pandit Deen Dayal Upadhyay Energy University. They have established a heating and cooling system at Dholera with using the 68 degrees centigrade. And they have tried actually even a power plant, power generation also, binary cycle power generation with support of some hybrid method, but it's not a very successful one, but it's operational occasionally. Then hot springs in NER, I think, particularly in Jakram and Tawang, they are worth the photograph of the team, Sri Ram Institute, GSI and SCCL, which has been instrumental in putting 20 kilowatt this geothermal power plant at SCCL Manuguru, and this is the flowing borehole there. So what is the present status in India? The present status in India, drilling is taken up in Puga and Ladakh by ONGC for generation of power 1 kilowatt, 1 megawatt power plant. Spring water is mostly used for cooking, etc. purposes. Medium extraction is presently going at BARC Bakreshwar. Tourist attraction places is at Tatapani, Ganeshpuri, Tural, Unavari, Khed, Bakreshwar, West Bengal, etc. 10 kilowatt and 10 kilowatt power plant at Manguru. And number of standalone activity and research exploration is done by different organizations, but they are doing in isolation. I think it is required to have some common platform where there is an exchange of data. The possibilities here, binary cycle power plant can be done Tatapani, Chhattisgarh, Puga, Ladakh, Ural, Ganeshpuri, Manuguru in Telangana, Manikaran in Himachal Pradesh, Anoni, Samoni in Madhya Pradesh, and hot spring of Tawang particularly. Tourist attraction places, particularly what we call hot water baths and spa centers, can be done in all these places. Refrigeration and greenhouse cultivation in West Coast Asia, West Coast of Maharashtra, Puga, Ladakh, Tatapani, Manguru, Joshimath. This is a very important but neglected hot spring. Some hot springs of Gujarat. This can be refrigeration and greenhousing can be done. Extraction of helium and argon at Bakreshwar. And there may be some other places also where if we have some detailed study, we can get extraction, means possibility of helium extraction. And extraction of lithium, borax and Puga. At these three places, it is possible. Desalination plants can be put along West Coast. And it's, no doubt, I don't know how far it is feasible, but particularly the solar energy, solar thermal, if we utilize for heating the water purposes, that can also can be stored, putting in the hot water in the low temperature reservoir as a store of heat energy, which can be extracted as and when required. Just done. Just done. Constraint cost of geothermal production is compared with the solar power, which solar power is presently very cheap, but initially we were given incentive of almost 40 rupees per unit. So that should be considered here. State governments are yet to form any process for giving geothermal project approvals. The authorities are not aware of the utility of geothermal energy. It has less potential as compared to solar energy. That is what the impression, but it is more useful in development of remote areas. Exploration is expensive, geothermal exploration. Deep level exploration is required. Funding is presently not easily available, and scarcity of trained manpower, this is one major, and machinery, this is one major problem. Further requirements from the government side or from the industry side, policy for the geothermal exploration is very much required, and the rate of geothermal power purchase, if these two things are decided, I think automatically there will be a great impetus for the development of geothermal energy in India. Geothermal exploration can be considered as R&D activity, and accordingly, some R&D concessions, import duty concessions, etc., can be given for that. Finance should be made easily. There is a gap funding is required, or assistance for geothermal exploration and power plant installation. If these two things are taken into consideration, it will be much useful. And government should think of at least putting one geothermal power plant with funding. This is done once if there is one showcase, we can say, power plant, demonstration power plant, automatically it will give a lot of impetus to the research and development of geothermal energy. Technically, common data repository is required. Presently, there is work in isolation, so data is also isolation. So there is no common planning for geothermal work in India. Made in India initiative may be encouraged. The way Sri Ram Institute has taken up initiative, such type of initiatives should be certainly given impetus to have a local power plant generation or local drilling capacity. Suitable training program, this is one major important aspect, and I think I thank NGRI for taking up this workshop, because suitable training programs is required to prepare skilled manpower in the geothermal area, and R&D initiatives also should be taken up to extract byproducts, particularly for societal or industrial benefit. This is last slide, don't worry. Assessment of important geothermal field is required, so that revised heat flow map of India and reassessment of potential with the different technology, improved technology, we can have certainly better results of potential, and planning can be done accordingly. And priority for the development of particular fields, that should be decided. Preparation of geological map of geothermal map of India, then site-specific utilization schemes. These are the two things. If we take prepare a proper map with reassessment of the potential of different fields, then depending on the socio-economic conditions, we can have some developmental programs, socio-economic programs for the development of particular area also. Preparation of geothermal development plan and manpower development scheme. A sort of institution dedicated for this is required. Direct heat uses can be encouraged. Public awareness program, particularly for the geothermal, should be taken up. ISRO has taken up a very good initiative nowadays. ISRO has a bus which is explaining all the activities of ISRO, including the present Chandrayaan. It's not, bus is not required, but the particularly major institutions which are doing the work, they should be put in we can say WhatsApp or such type of social media for geothermal, knowing the geothermal developments and geothermal work. Coordination between the government and private sector is required for the development of geothermal prospects. This is one major aspect. Policy decision, coordination with the private sector, and the rate, some sort of rate fixation for the purchase of the geothermal energy developed. These are the three very important requirements. Forming a geothermal association to coordinate the activity with private sector and the government sector. This is my thinking, that there should be some sort of group which can coordinate with the private sector as well as the government sector. There is no association, there is no group which is dealing with the geothermal. So if such sort of is there, there can be some interaction with the government, and there can be certainly some midway for discussion or development. I think conclusion, I don't have to go. This is also I don't have to go. My sincere thanks to Dr. Prakash Kumar, Director NGRI, and Dr. Labani Ray, taking initiative in organizing this workshop of geothermal energy and giving me opportunity to come over here to review the perspective of the geothermal energy in India. Thanks to Dr. Saraswat and dignitaries for their graceful presence here. And I dedicate this particular talk, Dr. Ravi Shankar, late Dr. Ravi Shankar DGGSI, and late Srikant Deshpande, he was Chief Engineer CREDA, for their untiring efforts to develop the Puga and Tatapani geothermal pits, because of which ultimately, at least we have reached to this stage. Thank you all for patient hearing.
Thank you, sir. I now invite Dr. BPK Patro to deliver keynote talk. And I also requested all the speakers to deliver their talk within the time.
Yeah, good afternoon, everyone. Very lunchtime. I'll try to keep it more interesting so that we'll reach. No, no, no. Today morning we heard very energetic talk from Dr. Saraswat saying that regaining the interest in geothermal. That is very aptly, and today we are here to discuss about the geothermal possibilities in India. This is the map that I think he has shown, which shows the top 10 geothermal countries, which is recently compiled in 2022, and we don't find India there. Whereas US and other countries, they are doing enough. Don't have any place here right now. So what Dr. Labani in the morning presented, the different geophysical methods that are required to explore to map the geothermal resources. One among them is magnetotellurics, he mentioned. So I'll be dealing with that particular technique, magnetotelluric technique. Why? Because this technique has the capability to make the prospecting geophysical prosperous field to a prospecting field. That is where MT comes. I'll be quickly going through the importance of MT and how it is useful for geothermal exploration. I'd like to thank our director, Prakash Kumar, and Labani Ray for giving me this opportunity to present myself. And mention that the MT group in NGRA has very bright past, and it is all the different directors, starting with present directors to all the past directors, have encouraged us to and believed in MT for its application. Starting, one of these major work that we carried out in Saurashtra, where Professor Gupta has believed application of MT for submersible imaging. That is how the MT technique has grown in NGRI. And all my present and past colleagues who has contributed a lot for this development of MT. Also, I have been learning a lot of things on 3D inversion of the MT data from my collaborators, Gary Egbert, Wei-Sima, and Henry Brasse. And these are my students who have contributed, developed some of the techniques, how to deal with different problems like the topography corrections, or we have a problem of the handling the different kind of data sets, because noise is challenging. So we have developed a new technique for handling the noise. Most of the projects are funded from Ministry of New and Renewable Energy. We acknowledge them. And one of the recent work that we did for Tatapani was in 2015, where we revisited Tatapani. It is funded from NTPC and also from CSIR. So we heard a lot about the geothermal systems, different type of geothermal systems, but my presentation is here with respect to electrical distributed technique that you're talking about. We have in ideal geothermal system, we have a different things like a heat source, a reservoir, and a fluid. You see the different systems with enthalpy based, then we call it a volcanic geothermal system and non-volcanic geothermal systems. In the case of high enthalpy systems, have a scenario like this. We have the top cap rocks, they are smectites, ilmenites, ilites, and they are represented with a low resistive bodies like less than 10 ohm meter, whereas the source, they are bit resistive than this, at around 100 ohm meter, and the heat source. So this kind of scenario plays an excellent playground for us to study its resistive properties, which do it. Coming back to low enthalpy region, in Indian system, it is like this. We don't have a specific model what we saw in the high enthalpy region. Yeah, the thing is the source, the meteorite water that goes in and it gets heated up and it comes up. So this scenario may change from place to place. We don't have a specific model for this. I'm trying to tell why this electrical conductivity is important, because we have different dissolved salts. They are embedded in these geothermal fluids, which make them as a conductive electrolyte. And these fields, they're associated with faults, fractures, and different shear zones, which act as a conduit for the geothermal fluid to come up. And hence, MT plays a major role here. A number of questions to be asked to go for exploration of these geothermal resources. First is identification of this reservoir. Then boundaries to be mapped, which will tell us the life cycle of this geothermal system. possible drill locations, map the different cap rocks, what I said, the nature of the cap rock. That is where MT can drill all these questions. Give a brief background of this technique and its capability. This is basically depends on the skin depth principle. You have the depth of penetration, which is proportional to the restive of the subsurface and the period. For example, if you take 3 waves, the high frequency wave can measure up to shallow depth. Similarly, if you give it longer period, they go up to very deep. The idea behind this is that if you use this electromagnetic technique, if you use this technique, then you can image the subsurface from hundreds of meters to hundreds of kilometers. That is why the technique is becoming more used worldwide for mapping thermal resources. Sources, in this case, we don't use any natural sources. These are artificial sources. The source comes from 2 parts. One is ionospheric sources. You see, that's magnetic field. They get interacted with the ionospheric sources get interacted with the Earth's magnetic field, and then they try to generate this EM wave, which comes and interacts with the subsurface and gives back us the secondary currents. Other sources, they are the thunderstorm activity. They are the high frequency sources we call. Any time of the day, we can see the thunderstorm activity going on. These 2 sources they are the input data for us, from where we can get from the high frequency to the from the shallow surface to the deeper surface. A small movie, what it shows is that how this interaction of the input wave, which interacts with the body, impacts any of these conductive or resistive bodies, and they generate the secondary EMF, and that are being measured through these induction coils. This is how this data is being acquired. We have 5 components, 3 magnetic field we measure and 2 electric field we measure. And using these 5 components, we derive the impedances of the subsurface, which in turn gives the conductivity distribution of the subsurface. So just for the clarity's sake, when we talk about the MT data, broad range, I just plotted here 3 kind of MT data. The AMT data is very high frequency data, and then we got broadband data and LMT data. So whenever I'm talking about MT data, that means I'm talking of everything, but depending on the target, we use this kind of data sets. So what is happening now? Previously, people have worked on different regions using the MT data, but the people have used only some part of the MT data to interpret it. For example, what we measure is all the 4 components. What you see is that we've got 4 curves here. You only use 2 curves to interpret because you do 2D interpretation. As a result of which, we do not get complete information of the subsurface, which I'll show you one of the example, what is the problem we have. So now we started using all the 4 components. For this reason, in 2015, NTPC approached NGRA to relook into Tatapani data, where we do the 3D inversion of those things. So this is a very nice thing which shows the use of resistivity. Any of these rock types can be compared with the different resistivity things. So once you get a resistivity image, you can interpret it in terms of the geology. And the rocks that we properly connected, that is also important. If the rocks to be connected, they also show in the form of resistivity. They need to follow certain criteria which is required to get the connection. So I just bring it back to you here. MT can deal with geothermal targets. Very important figure where you can see that each part of this structure, this model, can be converted to a resistivity image and which can be detectable. Saying MT, we also have to look into other methods, other geophysical methods like gravity and MIT methods. They're very important. But for just because the conductivity is our proxy here, so we use MT to derive the structure. These are the locations where, if you see the Asian context, there are many, these are the places where they use MT extensively to map the subsurface. Some of the published literature I could access, but otherwise, a lot of data is available which are not published here. CRA worked all these regions, in Tatapani, Puga, Badrinath Tapovan, Lohari Nagpal, Uttar, and Surajkund. Not only that, we also worked in abroad, Bulgaria, and I'm happy that today Dr. Harinana is here, who has worked extensively for geothermal mapping in India, who has created all these programs. Not only NGRA, I think there are a number of institutes in India who are also actively involved doing MT studies. Recently, I saw one paper from Manguru, they have done an MT study, and also I think in Gujarat, PDPU and ISR, they have also did studies. ISM, they did studies. So, number of institutions are involved in doing MT studies. I will not take much time here, but I just wanted to tell that in 2001, we did MT study here. The details of this talk will be presented by Aziz tomorrow, but to make an update here that last year we revisited this area. This is the Puga area, and we have acquired additional MT stations. We also saw the extension of it. The reason for is that we wanted to do a 3D inversion, and also we want to see whether this zone, what you identified, how it is extending laterally and all the directions. For that region, we acquired additional stations here. And the Chumtang region, what Professor Saraswat was mentioning here, we also had new MT stations here. The data, we are looking into that. And right now, as I speak, my team is there. We're acquiring MT data in Panamic region. Yeah. This is nearly 10-kilometer stretch area here. 20 kilometers we're taking here, right? One study that I wanted to show you from Tatapani. Did this study in 1998 first. We had a number of stations occupied in Tatapani, and then 2D inversion was carried out during that time. As I said that in 2015, we went back there and acquired additional stations so that total we can have 65 stations which can have a graded pattern here. The idea is that what we are seeing below. So this is a Tatapani fault. Not only that, we also did control source AMT along this small grid, a small profile, very close spacing. So what you see is that once you run the 3D model here, what you see, this is a Tatapani fault, and we got two very nice conductive conduits which have got deeper connection. You see the deeper body. But you see the MT has also problem, like if you get a conductor, then we do not get the base of the conductor because of frequency problem. So here what we did, we used broadband frequency range. So by seeing this conductive body, and we also planned another survey so that we want to long period MT. So we want to go beneath that body. Can we go there or not? So the advantage of doing 3D MT is that you can really scan the earth, see how these things are developing. See these connections, what you see from the deeper to shallow surface, and then suddenly this is disappearing, and this normal granitic crust is appearing. So this is near Tatapani where it comes. And this particular one is shown as a hot spring, but other one is hidden. This one is hidden. After coming some time, you see this is undisturbed crust. Suddenly it is coming up. So this kind of view one can see, and this will helpful for any exploration agency to plan their strategies and also find estimates. This is how we work out on this thing. So as I mentioned, this is the Tatapani area. What we did, we went for a long period data now, a long regional profile. And what you see, we are getting huge conductive body. So this we wanted to understand what could be the source for this. And if you understand this, then its sustainability can be mapped. Because many of these fields, they go up to 10 years, then they come down. So this will have some strength for us. I wanted to just, I will not bore you further, but I'll just bring you a few examples in the Asian region, how people are doing. China is aggressively working on this, and they have got huge number of stations. But in very earlier data, they use empty stations here. This is South China, and they could map this reservoir, which is only 5 to 10 millimeter, with a cap route. Why I'm showing that this is the efficacy of MT to image the geothermal reservoir. In another area in the northeast China, they did the similar thing. See, this is how they go. They did a lot of modeling stuff here, but finally they could drill in the location what MT has shown there. Another study in Japan where they used AMT studies. I'm talking about the high frequency data only, AMT studies. They could map the reservoir and they could see the connection. See, this is connected like this. The C3 is a connected one. So these studies help them for drilling. One study where they were producing 65 megawatt power plant and it decreased to 50 megawatt. In 1995 they established and then 2010 it decreased. So they went for further studies. What could be the reason there? They have done a huge 3D study here, 3D grid here, and then they could plan their strategy to regain the power production. This is how the number of borewells are drilled, and MT has helped them to get this signature. And they also corroborated with the heat flow study, temperature measurements, and finally they could concentrate here. Thing that I told you, the importance of 2D and 3D, because what is the advantage of taking all these 4 components? This one study in Korea, what they did, this is the 2D profile, this is the area, these are 2 profiles, and this is the result from the 2D profile. Based on this, they were planned 2 bore wells, but then they felt that when they did a 3D inversion, the inversion was more suggestive than this. What they saw is this is a very good conductor. They thought they're hitting the target here, but that's not correct. So this has guided them to properly plan their drilling program, and the dipping part is also seen from the 3D model. So this is why this is very important to handle the empty data very carefully. I'll just give this example, but having said the importance of it, I also should bring some of the cautions that we take while doing the interpreting the empty data. This is one example where unsuccessful drilling due to incorrect use of empty technology. Rock was mapped, imaged. Based on that, the drilling was carried out and it was unsuccessful. So we have to be very careful in analyzing the empty data and interpreting it. That is what a word of caution here. They reprocess the data and they perfectly match with the drilling results. To summarize, what I'm trying to tell is that we have got many challenges and many things to be understood for geothermal resource exploration. So different methods, the techniques are there to address each of them. But if you see them, then MT somehow plays a crucial role in identifying, mapping these geothermal reservoirs. So I say that MT has a slightly higher capability, especially for geothermal purpose. So in conclusion, well, it is very clear that it plays a crucial role, MT, but we also have to remember that integration of MT results with other CSEM data is also important to integrate both of them together, and rigorous 3D modeling of MT data, cooperative modeling and joint inversion considering the temperature, porosity, and permeability is very much important in order to really identify these zones. So while good conceptual model existing for high enthalpy regions, but for low enthalpy regions, we don't have a good concept model that is very area specific. At NGRI, we have developed a app which works on Android thing, where we have compiled all the published MT data, MT publications, MT models that can be downloaded. And also our group also developed a processing technique which is freely available, Python-based processing technique. Those who are practicing in MT, they can download this, they can make use of it. Thank you very much. And I welcome tomorrow, there is an open day and we have empty exhibition. I welcome all delegates to visit our stall so that we'll get a very good glimpse of empty data, how we acquire and how they process. Thank you very much.
Thank you, sir. We come to at the end of morning session of the workshop, but before that, there is one announcement. I just now invite Dr. P.B. Sirolkar, retired DDG, and Shri Vishal Sakre, Director GSI, to present memento from Gondwana Geological Society to Director CSIR-National, Dr. Prakash Kumar.
Good afternoon, everybody. Incidentally, I am a secretary of Gondwana Geological Society also, which is actually Geoscience Society in Central India. And we arranged one workshop on energy resources in June. Dr. Prakash was actually invited there, but because of his heavy schedule, he couldn't personally come there. His blessings were there. And he has helped us a great in organizing a seminar, which was successful. And we actually published a proceedings volume also of that particular workshop, a seminar rather, it was a 2-day seminar. So on behalf of Gondwana Geological Society, we are presenting a memento to Dr. Prakash Kumar. Sorry, I'm calling Prakash. So, okay. Prakash Kumar, Director NGRI, as a gratitude of Gondwana Geological Society for his encouragement in scientific activities of our Gondwana Geological Society. So I request the Vishal Sakre, who is the Joint Secretary of Gondwana Geological Society, to present it.
Kindly join us for the lunch, which will be arranged in the guest house. And the next session will be in the e-classroom ground floor main building. 2:30, at 2:30.